Welcome to our comprehensive guide on calculating the surface area of a cube. Today, we're going to master one of the most fundamental concepts in three-dimensional geometry. A cube is a special three-dimensional shape that has six identical square faces. Each face is exactly the same size, and all edges have equal length. Understanding surface area is crucial for many real-world applications. Whether you're designing packaging for products, calculating materials needed for construction, or solving engineering problems, surface area calculations are essential. In this comprehensive tutorial, we'll break down the surface area formula step by step, understand the mathematical reasoning behind it, and work through practical examples that will build your confidence and mastery of this important concept. By the end of this video, you'll have complete confidence in calculating the surface area of any cube, no matter how it's presented to you. Are you ready to become a surface area expert? Then let's dive in. Now that we understand what a cube is, we need to define exactly what we mean by surface area and explore the key concepts that will help us calculate it. Surface area is the total area of all faces of a three-dimensional object combined. Think of it as the amount of material you would need to completely cover the outside of the object. For a cube specifically, we can see three faces from this angle: the front face, the right side face, and the top face. But remember, a cube actually has six faces total. To better understand all six faces, imagine unfolding the cube like a cardboard box. This will show us every single face that makes up the cube's surface. Here we see all six faces of the cube laid out flat. Each face is a congruent square, meaning they all have exactly the same size and shape. The word congruent is important here. It means that if we measured the side length of any face, we would get exactly the same measurement for all six faces. Now, to find the total surface area, we need to find the area of all these faces combined. Since all faces are identical squares, we can find the area of just one face and multiply by 6. We highlight one face here to represent the area we need to calculate. Once we know this area, multiplying by 6 gives us the complete surface area. It's crucial to remember that surface area is always measured in square units. Common examples include square centimeters, square meters, or square inches. Before we move on to formulas, there's one more important concept: lateral surface area. This refers to the area of just the side faces, excluding the top and bottom faces. To summarize our key concepts, surface area is the total area of all faces combined. For a cube, this means 6 congruent square faces. Lateral surface area includes only the 4 side faces. And remember, all surface area measurements use square units. Now that we understand these fundamental concepts, we're ready to explore the specific formulas we use to calculate surface area. Now we'll discover the fundamental formula for calculating the total surface area of any cube. This formula is both elegant and logical once we understand its components. The formula is TSA equals 6 times a squared. Let's break down each part of this formula to understand exactly what it means and why it works. TSA stands for total surface area. This is the total area of all the surfaces that make up the outside of our cube. The number 6 represents the 6 faces that every cube has. No matter what size the cube is, it will always have exactly 6 square faces. The letter A represents the length of one side of the cube. Since all sides of a cube are equal, we only need to know one side length. And a squared gives us the area of one square face. Remember, the area of a square is side length times side length, which is a times A, or A squared. Now let's visualize this with an actual cube to see why this formula makes perfect sense. Here we have a cube. Each face of this cube is a perfect square, and we can see 3 of the faces from this perspective. Each side of the cube has length A. Since every face is a square, each face has the same dimensions. Let's count all 6 faces of our cube. We can see the front face here. The top face is the second face. The right side face is the third face we can see. There are 3 more faces we cannot see from this angle: the back face, the bottom face, and the left side face. That gives us a total of 6 faces. Now let's see why the formula works mathematically. Since each face is a square with side length A, the area of one face equals A times A, which is a squared. To find the total surface area, we multiply the area of one face by the number of faces, which is 6. This gives us our final formula: TSA equals 6 times a squared. This formula will work for any cube, regardless of its size. One crucial point to remember: always use consistent units. If your side length is measured in centimeters, your surface area will be in square centimeters. If the side length is in meters, the surface area will be in square meters. So remember, TSA equals 6a squared. 6 faces, each with area a squared. This elegant formula captures the essence of a cube's surface area in just 3 symbols. Now we'll explore a specific type of surface area calculation called lateral surface area. This is particularly useful when you only need to find the area of the side faces of a cube, excluding the top and bottom faces. Let's start by visualizing a cube and identifying its different faces. A cube has 6 faces total: front, back, left, right, top, and bottom. The cube also has 3 faces we cannot see from this angle: the back face, the left face, and the bottom face. Lateral surface area, abbreviated as LSA, refers specifically to the area of the 4 side faces of the cube. This excludes the top and bottom faces. The 4 side faces are the front, back, left, and right faces. Notice how we're excluding the top and bottom faces from our calculation. The formula for lateral surface area is LSA equals 4 times a squared, where a is the length of one side of the cube. Let's understand why this formula works. Each side face of the cube is a square with area a squared. Since there are exactly 4 side faces, we multiply a squared by 4 to get 4a squared. Lateral surface area is particularly useful in real-world situations. For example, when you need to wrap just the sides of a cube-shaped box, or when calculating how much paint you need for the walls of a cube-shaped room, or determining the amount of material needed for the sides of a container. To summarize the key difference, total surface area includes all 6 faces and uses the formula 6a squared, while lateral surface area includes only the 4 side faces and uses the formula 4a squared. This distinction is important for solving different types of problems. Remember, the lateral surface area formula is LSA equals 4a squared. This will be essential for the upcoming examples where we'll apply this concept to solve specific problems. Now we'll work through our first example to see how to apply the surface area formula in practice. Here's our problem. We need to find the total surface area of a cube that has a side length of 5 centimeters. Here we can see our cube. Each side of this cube measures exactly 5 centimeters in length. Let's clearly identify what information we have. We're given that the side length, which we call A, equals 5 centimeters. We'll use the total surface area formula, TSA equals 6 times a squared. This formula works because a cube has 6 faces, each with area squared. Now let's substitute our known value into the formula and solve step by step. Step 1, we substitute our side length of 5 centimeters into the formula. TSA equals 6 times 5 squared. Step 2, we need to calculate 5 squared. 5 squared means 5 times 5, which equals 25. Step 3, now we multiply 6 times 25. 6 times 25 equals 150. Let me clear the steps so we can focus on our final answer. Therefore, the total surface area of our cube is 150 square centimeters. Notice that we include the square units in our final answer. This is very important. This is a crucial point to remember. Surface area is always measured in square units. Since our side length was in centimeters, our surface area is in square centimeters. This completes our first example. We successfully found that a cube with 5 centimeter sides has a total surface area of 150 square centimeters using the formula TSA equals 6a squared. Now we'll work through a more challenging example. Instead of being given the side length directly, we'll need to find it using the diagonal of the cube. Here's our problem. We have a cube with a diagonal measuring 6√3 inches, and we need to find its total surface area. First, let me show you what we're working with. Here's our cube. And this red line represents the space diagonal, the longest diagonal that goes from one corner to the opposite corner through the interior of the cube. Step 1. We need to use the relationship between a cube's diagonal and its side length. The formula for the space diagonal of a cube is d equals a times the square root of 3, where d is the diagonal and a is the side length. Step 2. We substitute our known diagonal value. We know the diagonal is 6√3 inches, so we replace d in our formula with 6√3. Step 3. To solve for a, we divide both sides of the equation by the square root of 3. This isolates the variable a on the right side. When we simplify this fraction, the square root of 3 in the numerator cancels with the square root of 3 in the denominator, leaving us with a equals 6 inches. Step 4. Now that we know the side length is 6 inches, we can calculate the total surface area using our formula, TSA equals 6 times a squared. We substitute a equals 6 into our formula, giving us TSA equals 6 times 6 squared. First, we calculate 6 squared, which equals 36. So our expression becomes 6 times 36. Finally, 6 times 36 equals 216. Therefore, the total surface area of our cube is 216 square inches. This problem demonstrates an important skill. When you're not given the side length directly, you can find it using other measurements like the diagonal. The key is knowing the relationship between the diagonal and side length of a cube. Now for our third and most challenging example. This time, we're given the volume of a cube and need to find its surface area. This requires working backwards from volume to find the side length first. Here's our problem. We have a cube with a volume of 64 cubic meters, and we need to find its surface area. Here's our cube with a volume of 64 cubic meters. Remember, volume measures the space inside a three-dimensional object. Step 1. We start by recalling the volume formula for a cube. The volume equals the side length cubed, or V equals a to the third power. Step 2. Now we substitute our known volume of 64 cubic meters into the formula. This gives us 64 equals a cubed. Step 3. To find the side length, we need to take the cube root of both sides. This means a equals the cube root of 64. Step 4. The cube root of 64 is 4, because 4 times 4 times 4 equals 64. So our side length is 4 meters. Now we know each side of our cube is 4 meters long. Now that we have the side length, we can calculate the surface area using our surface area formula. Step 5, we apply the total surface area formula. Remember, TSA equals 6 times a squared. Step 6, we substitute our side length of 4 meters into the formula. This gives us TSA equals 6 times 4 squared. Step 7, first we calculate 4 squared, which equals 16. So now we have TSA equals 6 times 16. Step 8. Finally, we multiply 6 times 16 to get 96 square meters. This is our final answer. To summarize, when given a volume of 64 cubic meters, we found the side length by taking the cube root, which gave us 4 meters. Then we applied the surface area formula to get 96 square meters. This demonstrates how volume and surface area are connected through the side length of the cube. We've covered a lot of ground in this video about the surface area of cubes. Let me summarize the key concepts you've learned. The two main formulas you need to remember are total surface area equals 6a squared, which accounts for all 6 faces of the cube, and lateral surface area equals 4a squared, which covers just the 4 side faces. Remember, these formulas work because a cube has 6 identical square faces, each with area a squared. We explored 3 different scenarios in our examples. First, when you're given the side length directly, you can immediately apply the surface area formula. Second, when given the diagonal, you first find the side length using the relationship that the diagonal equals a times the square root of 3. Third, when given the volume, you find the side length by taking the cube root of the volume. As you work on surface area problems, always remember these important points. Include the correct square units in your final answer, double-check your arithmetic, and remember that total surface area uses all 6 faces, while lateral surface area uses only the 4 side faces. You're now equipped with all the tools you need to tackle any surface area problem involving cubes. Practice with different values and scenarios to build your confidence. If you found this video helpful, please give it a like, subscribe for more math tutorials, and let me know in the comments what topics you'd like to see next. Thanks for watching, and keep practicing.